set one, 24th January, right? So just wait for a few minutes so that maximum students can get benefit. So literally students, I can say there is one suggestion. Those students will go to write J main exam to, I can say, for coming date. Uh, Everyone, we remember, because I'm just giving you those topics which easily you can score well. So that is students, I can say, basically, it has a you have to just make a grip on unit dimensions error. Students, it's a highly required. Students, it's a highly required, right? And after that, students, I can say you can also make a grip NLM, friction, because the students kinematics, right? These all are students. I mean, I can say highly required, right? Highly required. Just Risham. So now, students, I can say for this condition, I can say students already joined. So I have to start discussion, right, my dear? So I can say for this condition, what is the things, students, which we can go through this. So now, students, look, this is the first question. No, students, it's I can say class questions. Literally, I can say newly I discussed. Students, I newly discussed this numerical in the classroom. Right. So what question says students initially spring constant gestation. Initially, student there is mentioned K is what spring constants, right, student? Okay. Now, student, there is mentioned spring cut into two ratio. Okay. What is student? Spring cut into two ratio, that is 3:1. Find the spring constant of smaller length. Okay, students, here we wish to find what is the length of small spring, right? After cutting. So, students, I can say for this question, no, it's a very common question and pretty easy. Pretty easy. It's a class concept, student. So, have a look of the solution, my dear. I can say have a look of the solution, my dear. Right. So, what is students? I can say this is initially can take for consideration, my dear. This is spring, right? You can take a student's initial like spring constants k before cutting students. It's k, it's comma. L is what initial length. You can tell, my dear. K is what initial length of the spring. K is what beta? K is spring constant. L is initial length, right? Okay, my dear. In this question, what's the things I have to discuss? What is you need to what? You need to cut because according to questions, my dear, you have to cut this spring into different parts. In what beta? You can say this is what 3:1. So you can say one part you need to beta. I can say take for consideration. This is 3 beta what 3 L by 4. And second is what beta? You can say L by 4. First students, you can say this is 3 L by 4, and second student, what you can say L by 4. Okay. So what is the concept behind this? What is the concept behind this? Students, for this condition, what is it? I hope you remember. K is what? Inversely proportional to length. What, my dear? K is inversely proportional to length. Okay. If K is inversely proportional to length, beta Z, so L what you can write? 1 upon K. L what you can write? 1 upon K. So let us suppose you can take beta, this is 3L by 4. What is the spring constant for this one? You can say K1. This is what you can see student K2. Right. Okay. This is K1. This is what you can say K2. Okay. So we wish to find K1 and K2. So how can we do it, sir? No, this is K is what inversely proportional to L. You can write L is equals to what? 1 upon K. L is what beta is 1 by K. Here you can go through here. So what we wish to find K1. So K1 is what beta? Again you can say 1 upon till 1 upon L1. So this is students, I can say 1 upon L1. Okay, students, I'll do fast. L1 students, now you can see this is what L2. L1 what beta? You can get from L1. This is what? You can say 3L by 4. And this is L is what? 1 inversely proportional to K. So K1 beta, what you can write? This is 4 by 3K. K1 beta Z. K2 beta, what you can say? Again, you can say 1 by L2. This is L2, 3L by 4. And L is what? 1 by K. So this is what students you will get. This is 4K. This is what you can say 4K. So what asked in the question? They ask for smaller. So this is what smaller beta. This is what you can say smaller 4K. So what's the answer? K is mentioned one. That is what you can say 15 Newton per meter. K is been mentioned. That is what 15 Newton per meter. So finally you can write K2 is what basically is 16 Newton per meter. So this is student I can say answer for the questions. Right. Have a look question next. What's the next question is going? Have a look once. Again, I think it's a not a tough question. It's a questions from NCRT directly. So there is, I can see that there are two columns, columns one and two, X-rays, infrared, microwave, and radio waves, right? So in column two, no, beta, here we can go through what's the application of these all things. What's the application of these all things? But I can say there is one form that is what I can say microwave microwave, or I can say, beta, there is some error. Yes, microwave. Yes, beta. Hot bodies and molecules. Hot bodies and molecules, beta. You can say what? Basically, bacha, hot bodies and molecules applicable for beta. You can say only for this is X-ray. 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 What is X-ray? Highly accelerated charge particle incident on what you can say metal plates. So, beta, that is here. We are pretty confirm. X-ray is what? That is option number first. That is what students you can say option number S. X is the first option, and this is what beta S. So you can write directly fast moving electron strike a metal plate. So A is equals to S. So this is what here also matching S, here also matching S, here also matching S. So I can say this is I can say option first is out. Now infrared. What is it? This is what you can say infrared. Infrared is what beta you can say. This is what basically beta I know in hot bodies. Infrared design for what you can see students for hot bodies. So this is you can say B for P, B for P. Again, this again these two are common. I can say this is option four is out. Now option C is what? That is a microwave. Microwave beta, that is what I can say R. Beta, that is you can ask, sir, what is the magnet? What is a magnetron? What is the magnetron? So a magnetron is a high power vacuum tube that generate what beta? Microwaves by using what? Cross electric field and magnetic fields, right? So simply beta, you can see what is usage of magnetron. So concept of magnetron with usually students used in what you can say microwave, radar, and what industrial heating. So you can say for C, C is what magnetron beta. So C is you can say R. So this is I can say bacha D. What is the last option D? You can say that is what only Q. What's your answer for this question? That is option number second. Option number second, my dear. Now, students, have a look next question. So, what's the question saying? Telling beta, you can see there is, you can say a microwave has an objective focal length. Okay, it's not a microwave, my bad. Microscope. Microscope has an objective focal length 2 centimeter. Eyepiece of a force focal length. Students, you can write along with. During reading question beta, you can write the data. So that is what students you can write over here. Objective. This is what FO. FO is what, my dear? 2 centimeter. Students, very good evening. Sorry, this is Fe beta. This is, I can say beta, this is 5 centimeter, right? Tube length beta mentioned here. Uh, Tube length beta is mentioned. This is what, my dear? You can say this is 10 centimeter. In case of normal adjustment, beta, this is the point here which you can do underline. Student, this is what point which you can do underline. Student, for normal adjustment, it is to find what magnification. Student, it's no. These are I can say strong recommendation. Those students will go to write exam for coming date of JMIS. Be remember optical instrument. Be remember optical instrument. Right. So, beta, what is the formula, students? I'll not waste much time here. This is what magnification formula beta G you can use for this case. This is what tube length into D. D is what? It's normal. I can say distance. I can say that is we are using. D is what for normalize. This is 25. If nothing mentioned, then you can do use. D is what? 25 centimeter. This is what, my dear? You can say F naught into FE. F naught into FE. So further, student, you can just solve further here. So L is what beta we mentioned? L is what? 10 centimeter. You can take beta point one. And D beta, this is 25. D is beta 25. No need to worry. Just take beta in CGS first. 25. Sir, macroscope came in my JEE main exam. Yes, 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 yes. You're right, beta. This is a question repeated, students. You correct. You correct. You correct, beta. Ji. 14 to what? You can say to 25. F naught beta, what we can say? Sorry, F naught is what? Already mentioned here. This is 2 centimeter. Into beta, no need to conversion unit here because centimeter cancel each other beta. This is what 5. 2, 5 that in beta. This is cancel. So what you will get, student, for magnification, that is what 25. Yes, beta. This question I can say came in examination. This is a repeat telecast, student. This is a repeat telecast. Same question, the repeated data little change only. Now, beta, have a look at this question. I can say, beta, it's a very good question. I can say first time JEE asked. Last, I can say question started like 23rd, 21st, 23rd, 2nd, 23rd, and 22 is 24th. Finished all the part. JEE means first and second. This question little, I can say it's a good question. I can say it's a good question. So what student, what they mention? Potential is a function of R. What beta they mention here, that is what made here potential is what I can say function of R, right? If the student I can say potential is a function of R, so what we used to find, what is the charge? It's easy question again, student. Yeah, I see it's but it's a good question, student. It's a good student. Now students, I can say very good. I can say one student, Jeet Kira, very good bacha. So beta here, we used to find charge. No beta, I hope first you can write given data here. So what is the potential student? Sir, can you teach CRTM? I don't know what is the meaning. V beta, you can see this is A R Q plus V. Here student, I'm going to use that is relation. It's a class question, straightforward students. It's a class concept only. Here, student, I'm going to use that is, I can say, a relation between electric field and electric potential, right? Because there are two formula here. I can say it's a recommendation. Those candidates who will go to write exam. Students, here you can write this is what dV is equals to minus E. Okay, combined rotation. Yes, I'll teach you better. I'll teach you CRTM. Don't worry. If you want it, then I'll do it. Tomorrow I'll be live. Just I'll teach concept only better. So this is you can use better this result if they mention electric field and to find potential. It's a recommendation. Those candidates will go to write the exam student. If electric field mentioned, if you want to find potential, then you can use. Then you can use. I can say, bacha, just move next. What a student for this condition? This is I can say better first relation. So tomorrow I have exam. Tomorrow is Sunday. Tomorrow is no exam at all. Which exam will go to write? Okay, maybe class test. Yes, beta. This is second question here. Beta, here you can write if they mention potential, if we used to find electric field. Ah, yes, got it, beta. Got it. Nitin beta. So E beta is what? Formula you can use minus dabba V by beta dabba x I cap minus beta g. You can see dabba V by dabba by j cap minus dabba V by dabba j k cap. Now, beta, it's a very common question. Sorry. Now, bacha, here they didn't mention anything. So we can take X is R or R only, bacha. So first I'll differentiate. So electric field will get beta. This is minus dava. This is what beta? ARQ plus B upon beta G. This is what? R only. You can write beta. So, B is constant bacha party. So, what you will get? Minus beta what? 3A R square. Right. Beta minus what I can say. Sir, I have a questions on Bernoulli's principle. Okay, students, I'll help you. I'll help you. I'll help you. I'll help you. Wait, wait. If you have questions, queries, you can just say me. I can say like on a Telegram channel of Physics Mind. I'll see and back to you. So now, beta, this is what you can see 3R square. What would say? You can see this is 3R square. We wish to find basically charge. So, beta, what is how can we get charge here for this condition, beta, for getting charge? What we can apply, beta, principle? Sure. Till beta further, beta party. Use beta concept of this is I can say beta. You can see it here. This is for this question, step one. Now, beta, this is step 2, beta, sure. Beta, here I'm going to use we know everyone. We know everyone. This is what, my dear? Flux is equals to E into A, and this is what? Q enclosed by epsilon F. Q enclosed by beta, what you can say epsilon F. So E beta already we got. Minus is what representing? Only convention of sign here. So no need to take minus here over here. This is what beta you can say 3AR square. And they mention what? Sphere. This is sphere R. So it can also say beta this is R square. What is area of a sphere? Tell me here 4 pi R square into this is what? Beta Q enclosed here. Option just beta do just to cross multiply beta G. What you will get beta? If you do cross multiply, student, if you do cross multiply beta, what 4 3s are 12. So students will get Q basically 4 3s are 12 A 4 pi r to the power 4 epsilon L. So this is which option बच्चा जी? I can say this is option बच्चा. Options number C. This is student. I can say options number C. Now बच्चा, I can say let's move next questions. What question says? For the given circuit, find the yes, Canada. Correct, 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 Vita. Correct, student. Sorry. Find for the given circuit, find the power factor. Sorry, tell what is formula power factor? Sorry, tell what is the formula power factor? You know, beta, this questions here, literally, I can say, bacha, we just go through formula straightforward. In fact, no need to apply, I can see to find Z, R, L, like these all things. So, beta, power factor formula, you can write, my dear, this is what? One R factor is what? You can say R by Z. So R beta what? This is 60 ohm. So beta Z you can write, my dear, power factor. So R beta how much? 60 ohm. Beta for Z finding, you know what is formula of Z? I hope all of you remember. This is what, my dear? R, you can say, bacha, this is R square plus XL minus XC whole square. Because you no need to convert, no need to find XL is 1 by omega C and XL is equals to uh, beta this is omega into L. No need to apply this thing because they already mentions in ohm only. Be careful during solving the questions. It's a very common, I can say, beta error done by student during the paper hall. So student here I'll write, I'll use directly bacha. So this is what beta R square. We can say this is 60 whole square. XL beta, this is what? XL 70. So 70 and beta, what is bacha this one? This is, you can say beta 150. This is beta how much? 80. So this is beta, you can write 60 whole square. Means this is 3600 plus beta ji 64. So beta, how much will you get here? This is I can say beta 10,000 here. 10,000, or you can say this is what? More than that. So beta, this is you will get beta what beta tell me here? It's 100. Am I right, sir? Sir, am I right? Okay. So beta, I can write here over here only beta. So what you will get? This is what? 3 by 5. Which is option Bombay is correct. Option Bombay is correct, my dear. Okay, beta. Now have a look next questions here. Have a look next question, beta ji. Yes, yes. Hare Krishna, student. I'm very happy to see you. Hare Krishna, beta. Now I can say, beta, this is the questions. Next question, student. Figure shows. Yes, beta. Correct, sorry. Figure shows a meter bridge. Initially, a null point was achieved at P. Beta, you can take. Initially, this is the P. This is what, beta? You can see this is the P. Okay, there is diagram here. So what is the diagram, beta? I can see this is, there is mentioned, but this is 2 ohm. This is what, beta? 3 ohm, right? So what's the in the next question? Is this J? Yes, yes, student. I'm discussing students only. I can say, beta, that is J questions today morning. Today, first shift question students I'm discussing over here. So this is beta 2 ohm. This is 3 ohm. First time students, I can, there is a deflection point, right? Okay. Then beta, I can say for this condition, what beta? We have to find unknown value of r. What is this condition, student? This is I can say which I'm going to solve this part questions. I can say case one only. Okay. So case one beta, what say this is? You can say beta. Everyone. What's the length of the barrier? What's the length of the bar? This is 100 centimeter. So this is beta, you can say 100 minus x. What's the question here? I can figure through the meter bit initially null point was achieved at point P when an unknown resistance R is connected in parallel. Okay, so initially beta there is a, I can say beta things, right? In 2 meters. Okay, now, Bachaji, here, first beta, I'll apply the same principle here. This is, I hope all of you remember, this question repeated multiple times here. Almost, you can say this question be a part of potentiometer as well. So, beta, you can write over R1 upon L1 is equals to beta G, R2 upon L2. Simple beta, my dear. Uh, then, Bachaji, yes, student, this is JE question only. R1 beta, this is 2, x1 beta, this is L1 x beta g, this is 3 beta, this is you can say 100 minus x. Beta will get x from here. Do beta cross multiply 200 minus 2x is equals to 3x beta g. So 200 is equals to 5x my dear. So what we will get? Just tell me here. X is equals to 40 centimeter. This is one which I found. I can say for case number one. Okay, now students, I wanted to discuss case 2 as well. So what is case 2, my dear? In case 2, what they mentioned, this is remains, you can see 2 ohm, it's a resistance box. Now student, this is remains 3 ohm, there is no change. What's in the questions? After connecting one unknown, this is remains 3 student. After connecting one students, you can say unknown resistance. What's in the question? I can say balance point shifted. Balance point shifted. How much here? Shifted. Means you can say initially here. Next is what shifted. Right. Okay. Then beta see. This is a highly important question. How you are telling you don't know this formula? Beta, it's a super important beta. It's a highly important. I can say it's a recommendation for those candidates will go to write Jamin. I can say for coming days. So, bacha, here this is this beta we can apply simple thing, bacha. Again, we can apply same thing. This is R1 upon L1 is equals to R2 upon L2, my dear. R1 remains 2 only. What's this beta? Initially x. How much shifted? 22.5. So you can write, my dear, this is x plus 22.5 is equals to dear R2. No, these are in parallel. So I hope all of you remember. Student, I can replace these two resistors using formula R1 into R2 upon R1 plus R2. Okay, hello student. Now beta. So I'll use R into 3 upon beta. This is R plus 3. So student, I'll use same principle over here. Right, my dear? This is R into 3 upon beta. This is R plus 3. And L is what beta? L beta what we can say? 100 minus X beta plus 22.5. Right, beta? This is highly required here. Then bacha, I can say, just beta do cross multiply. This is X beta known for us here. We can simplify. Beta how much? 40. So you can write bacha, this is 2 upon what beta? 62.5 is equals to 3R upon beta z 3 plus R. This is what? 100 beta. You can write 100 and this is beta x no? Minus x beta z. Minus beta, this is, you can say 22.5. This is beta what we can say? 42, 62.5. So 100 minus 62.5 beta. How much will write here? 100 minus beta z is 62.5. Tell beta, sorry. Sorry beta, how much will you get here? How much will you get beta? Sorry beta. This is 5 here. You can see this is what? Bacha 9, 2 bacha. This is 7. Beta, this is 9, 6, 37.5. Right, beta? So you can get this is 33.5 here. What will get finally? 5, 10, this is 5, 9 minus 2, this is 7. Beta, this is 9 minus 6. 9 minus, correct only? Minus beta x 42. Yes, beta. Now, beta ji, just we'll go through this here. Further, you can solve it. So, x beta, how much will you get here? Just see, x beta 22.5. So, this is 3 plus r into beta. 3 plus r into, you can say, this is, there is little calculation, but error here. So beta, this is 2 by 62.5 is equals to beta. This is 3r upon 3 plus r into beta 77.5 minus 40. That is fine. Then beta ji, what you can say, this is this beta do cross multiply. So this is 33.5 into beta 2 is equals to beta, or you can also say na, or you can say beta, this is 3 plus r is equals to beta 62.5 into 3r. Simple beta. Further, you can solve the property. You will get r is what? This is 2 ohm. R is what, my dear? R is equals to 2 ohm here. Okay, have to put next here. Now, bacha, I can say just beta. Next questions. Beta, this is again your questions. It's literally pretty easy question. Pretty easy question. Repeat questions here. Find reading a voltmeter. I can say this question I did multiple time in classroom. Multiple time I did in classroom, student. Right. So here, bacha ji, I can say this is these two are in parallel. What we have to find? Reading a voltmeter. These two are in parallel, beta. What we can say? 400. Just solve questions here quickly. Just replace bacha body. This is I'm just finding a R equivalent. So 400 into 100 upon beta g 500 plus beta what you can say 100 here. This is cancel. So beta R equivalent you can write 400 by 5 plus 100 bacha. So R equivalent beta how much will you get here? This is 900 by 5 ohm. So beta R how much will you get here? I bacha. This is V by R. So V beta how much here? This is tell bacha ji. This is V 9 beta and R is what? 900 into 5. This is cancel. So this is beta will get 1 upon 20 ampere. So you will get current is what? How much? 1 upon 20 ampere. Right, my dear? Okay. Then bacha, we have to find potential. There is a short trick here. There is short trick beta. Hello, Shreyans. How are you, beta? This is student, this is 1 by 20 ampere. Current beta will come from here. Student, from here, student, current will flow. This is 1 by 20 ampere beta. Okay, sir, your writing is not good, but please teach me. Okay, student, just I'm writing thoroughly here. I'll try. I'll try to beta write slow. Then it's about a bit more better for you, beta. Now, this is current I student, right? This is current. There is a reminder that yes, student. Tomorrow I'll take you to class. Tomorrow, students, Sirans, I'll take you to class. I'll start beta Z. I already planned, right, my dear? Tomorrow, students, I'll take your class, and that is students 12:30. 12:30 beta, I can say afternoon, right? And students, I'll teach that is what, my dear. This is gravitation. Tomorrow I'll discuss beta in detail. Only one factor, that is, I can say beta. This is what here, gravitational force. Tomorrow, students, I'll just cover beta first topic. Right. Yes, from basics only. Don't worry. Shreyans at physics point, explanation also I'm doing a very, I can say, like beta. I can say it's slow here. This is what here I can say, Bacha ji, beta, I'll start from this is zero level to beta. This is what I can say, beta, desired level of J advance. Right. So tomorrow class, beta, I'll just go through this only, beta. Class 11th is gravity. This is beta class 11th only, Shreyans. Now, beta, have a look. Now, beta, this is short trick here. This is current beta here, and this current will divide. Beta, this is I1 बच्चा जी, this is what my dear I2. Ah, yes, tomorrow you will see a realized class, because now it's questions I'm just solving you, right? Students, I can say just watch tomorrow class. You will enjoy the session here. I'll teach you advanced, but you can't imagine it's a tough. Literally, it's very easy, beta. Now, beta, this is short trick here. Just I'm using over here. This is current I. This current divided in two parts, I1 and I2, beta. If you are finding this is beta R1, this is R2. So I'm telling you, this is R1, this is R2. It's a short trick here, super important. So, if students, if you are finding I1, so beta, what you can use the formula R2. This is R2. Just opposite, reverse beta. R2 upon beta R1 plus R2 into my dear. This is I. So what is R2 beta? This is 400. Be careful beta. 400 upon beta g 500 into beta g 1 by 20. You can say this is cancelled. This is what beta you will get 1 by 25 ampere. It's actually pretty easy formula to get, I can say, current from any circuit anywhere. Now, bacha, this is I1 I found here. We wish to find I2 because we wish to find what is the potential drop on the, I can say, beta, this is the 400 ohm bacha party. So this is what beta again I'm using R1. If you are finding I1, then you have to write I2. If you are finding I2, then you have to write I1. Then beta R1 upon bacha this is remain same R1 plus R2 into my dear I. What I beta R1? This is 100 my dear upon beta what you can say 500 into 1 upon 20. This is cancel beta. So what you can write 1 upon 100 ampere. What you can write better, this is 1 upon 100 ampere. We wish to find potential drop. In fact, beta, this is beta known. This is the basically voltmeter over here, bacha. So what students you can write finally V beta you can write V is equals to IR. So what is I bacha? Already be found 1 upon 100. And what's the resistance bacha party? This is 400. You can cancel. So this is beta C 4 volt answer for the question. Right, my dear? This is 4 volt beta. Option number C. This question I can say recommendation for those can will go to write exam student. Now students, have a look next questions. What question says a branch rod is fixed rigidly across I can say supports, right? Because he built it without any tension in rod, 27 degrees Celsius. Now, as it is cooled to minus 43 degrees Celsius, the tension becomes two. I can say with that tension becomes what? It's a T naught, right? The temperature at which the tension will become 1.4 T naught. Okay. Now, what's in the question is equals to, we wish to find basically x, negative sign you can ignore, right? Value of x is what? Right, my dear? This is the basically questions. This is what, dear? You can say basically questions. So I can say this question literally just now I finished in class. You can use what? Concept of mass, mechanics of solid, thermal properties, I can say mechanics of solid. There is a concept, student, thermal stress and thermal strain, right? So student, here I'm going to use thoroughly. That is what? Thermal strain formula, dear. So this is, student, I'm going to use here thermal strain formula. This is what, my dear? Thermal strain. So this is, you can see delta L by L is what beta? Alpha delta T. This is student formula from 11th class. From 11th class student. Now, here beta, what I can write, this is initially they mentioned, what's the temperature here? 27 degrees Celsius. Beta, what we can see, this is what? 27 degree Celsius. Okay. So beta, just 27 degrees Celsius. And next beta, what they mentioned? This is, you can say, Acha ji, 43 degrees Celsius. So what's the delta T here? What's the delta T? You can find delta T, bacha. So here, student, I'll just take first. I can say beta delta L. This is L into alpha, and this is what beta 70 degrees Celsius. Let us suppose this is options number A. This is what beta options number A. Okay, thermal stream, bacha. Now beta, what the questions? Initially, student, I'm going to use over here formula force per unit area means it's a stress is equals to what beta? Young's modulus. Young's modulus, it's a good question. Not, but I can say it's an easy question. and very strain beta, strain only. So what beta tension? Initially beta T naught. So you can write my dear, this is T naught upon A. Okay, T naught upon A is equals to what beta G? This is Young's modulus. You can see delta L1 upon beta G L. This thing beta, I can write directly over here. Then bacha, you can see this is options number B. Then say question bacha, this is tension becomes what? 1 by 4 T naught beta. Similarly, I'll use beta same thing. So before finding delta, students, I can say this is step 1, my dear. Now I can say this is step 2, student. So delta L, 2 I'll find first beta. So this is what L alpha, 27 degrees Celsius beta minus of minus x. We used to find this one. So delta L2 we can write beta. This is L alpha into 27 plus x. You can see here, this is option number C. Beta, again we have to write expression of tension. That is what 1.4 T naught. So you can write, my dear, again I'll use the formula F upon A Young's modulus into strain, my dear. So 1.4 T naught upon beta A is equals to what, beta party? Young's modulus delta L2 upon L beta. Right? Do one thing, beta G. First, I can see this is options number D. Student, first you have to divide these two options, B and D. Where I have to do, I can say pages is not much sufficient, beta. This is step 3, beta G. Beta, what I'll do, this is I'll divide beta G. This is, you can say, D by B. This is D by B, beta. You can say everything get cancel. What will you get? This is 1.4 only. Everything beta cancel. 1.4 is equals to what, beta G? You can write this is delta L2 by delta L1. Delta L2, delta L1, we already found. So you can write, my dear, you can write, my dear, this is 1.4, 1.4, beta G, 1.4. Delta L2 is what? This is L alpha 27 plus x, and delta L1 is this is L alpha, this is 70 degrees. You can see this is entire thing is cancelled. Student, just to cross multiply. Beta, this is, I can say, step 4. So this is 1.4 into 7 beta. This is what you can see, 98. So this is 98 is equals to beta G, 27 plus x. Beta x, how much will you get here? 98 minus 28 minus beta, 1 only here. 9 minus 2 beta. How, what will you get? This is 71 degrees Celsius. So beta, what's your answer? You need to suppose your answer student in the paper hall. This is 71. Minus sign already I have taken. Minus students already I have taken. Right, my dear? Okay. Now we have a look next. Oh, it's a pretty easy question and very easy. Literally, it's a very easy, but it's a good question, student. No, I can't say name of any book because these questions I read in the classroom. I read in the classroom, right? So beta have look questions there. There are this beta economic questions. Three uniformly concentric charge cells are kept as shown. Find potential of each cell. Okay, so student, there are A Q1 charge, B Q2 charge, and C Q3 charge. No, beta, what is the logic for this question here? Just go through logic of this question, student. You will enjoy. Now, beta, I can say for this solution. I hope this I'll see here. This is little points about, I can say, concept on beta potential, right? Beta concept on potential. What is the concept with Chapati? You can tell this is with Chapati. I'm just considering radius R. Charge is Q. So this is, I can see beta, there are case one I'm considering. This is R is equals to R. Means you are at what? I can say boundary of the surface is. So this is, you can write beta potential, which is KQ by R. This is KQ by R, right, beta G? Okay. You know, this is R only, capital R only, because R is equals to R. Students, here I'm writing, this is, I can say, case number 2. This is, you are outside the surfaces, R greater than R. So, student, for this potential, what you can write? KQ by small r, right? Now, bacha, just one advanced thing I'm just telling you as a prediction. Keep in your mind because this question's common here also, gravitation as well, right, my dear? What's the nature of graph here? You can see for I can say from center till center to boundary, this is remains constant. So you can say graph like this. After that, students, you can say this is what graph message or rectangular hyperbola. Have a look at these questions here. I can say which question we wish to find potential at A. Now, beta, you can just make yeah. This is we wish to find potential at A. Beta, this is a charge. You can say spherical cell. This is what? You can say charge Q1. Radius is what A. You can write beta due to what? A surface potential due to this charge. Only this charge beta. What you can write? This is K Q1 by A beta G plus. No, this is a sphere which is inside of there are two sphere. This is what, my dear, inside of two sphere. So this is beta mentioned Q2. This is what Q3. So here for this, I can say sphere. These two are outside. So I hope you remember. Outside is what we can write. KQ by is smaller. So what charge is which? You can write over here. This is KQ2 by beta G B only. Because what's the dimension? What's the dimension, bacha? Then, bacha, you can write for next one. This is KQ3 by because this is where this is outside. So this is remains constant here. So potential at A beta. Now, students, I'll write potential at point B. So this is beta. For this condition, what you can say, this is the charge Q2 beta G, and this is what B. So you can first write due to self, first write due to self, or you can say surface. So what, my dear? KQ2 by B plus beta. Listen carefully, our class. Beta, you know, there is one more sphere. But this sphere is what? Inside of this. You know, beta, from center to boundary, potential remains constant. Potential remains constant. So, student, what is the things which you can, I can say, bacha? Okay. Now, beta, this is B bacha party. This is, you can say what? Q2. Okay. Very nice, student. So, this is the things. Charge remains here. This is also fixed beta G. So, what you can write over here? This is KQ1 upon beta, this is remains B. Last beta, what you can say, this is another one. This is beta, you can see beta, this is C and charge is Q3 beta. You can write, my dear, KQ3 by C. This is what? Potential at B. Now, beta, we will find potential at C. No, beta, for potential at C, what is the interesting point? Literally, student, it's a very easy question here. Literally, very easy question, student. Beta, for this condition, what you can say, sir, these two are inside only. So C remains fixed. So simply you can write beta K Q1 by C plus, my dear, K Q2 by C plus, my dear, K Q3 by C. So this is literally beta very easy questions, right? You can take some solution. Now we are have a look which option is correct. Which option is correct? So you can say, bacha, this is VA correct, VB bacha party correct. This is yes, beta. Option Bombay is correct, my dear. Student, option Bombay is correct, my dear. Okay, fine. So it's a literally good question, student. I can say concept wise. Now, student, have a look next question here. My dear, have a look next question, student. So what's the question says? Need dipole moment of the configuration. Okay, very interesting questions. Not tough, but you know, there is a concept student you can use. My dear, I'll go this question explanation little slower because at physics point, this is a dipole moment. Yes, beta, from 12th class, Shreyans. At physics point, here I'm not giving only straightforward solution of any questions. I'm trying to convey, also I'm conveying what is the concept behind this so that you can get benefit in the coming days of JMean advanced exam as well. Now, beta, so you know, this is a very common question. I'm just telling you, students, first, I'm telling you about my class questions, what I did in the classroom. Students, I can say, I think 12th physics have more. No, beta, this some paper it can feel like that, but it's not true always, bacha. You know what I'm telling you, beta. I'm telling you this question you can understand easily. Beta, ji, let us suppose in the classroom what I already did. This is minus 4q beta. This is 2q. This is 2q. Beta, what is the meaning of beta? I can say dipole. Dipole, beta, I can say is a pair of two charged particles. Both are same in magnitude and opposite in nature. But here you can't, student, I can say, perform dipole. Then what you can do, Bechaji? Beta, for this condition, beta, no, this is the concept which I can apply over here, right? Student, this thing you can break here. By dear, you can break. This is, you can frame minus 2q. This is 2q. It's a one dipole. Now, students, I can say there is another dipole beta. This is, I can say, minus 2q. And what beta ji? This is what? I can say plus 2q. Now, this is the dipole. Beta ji, these two are what? 90 degree. You can apply formula, I will get the answer beta, right? So this is the concept I can apply over here. How it's a party? This is 2q. This is 2q. This is minus 4q. So this minus 4q, student, I'll break into part. How should have look? I can say solution first. So this is what I can say better student solution number one. Now, students, here I'll break like this. This is I'll make first pair because this one I'll break in minus 2q minus 2q. So, student, this is I'm calling first pair. This is minus 2q beta. This is beta g minus 2q, right? Student, here, no, what's the distance is there? So, this is A, this is A. So, beta, this distance you can write 2a. Student, I'll go slow with it so that you can understand the student. Literally, it's a very good student. It's a very good, I can say, bacha, which I'm going to discuss you. I hope all of you remember. Let us suppose, beta, dipole direction. Always, students, you can say negative to positive. Students, dipole direction, always you can take what negative to positive. My dear, I'm calling here. This is what P1. My dear, I'm calling here. This is what P1, right, beta? Okay, so P1 you can write, my dear. P1 you can write. What's the formula of dipole moment, beta? Dipole moment you can write charge into separation of particle. Charge into what, beta? Separation of particle, beta, right? So this is what 2a. So what you can write, beta? 2 to the 4qa. This is what? Plus I cap. This is what, beta? Plus I cap. Now, beta, this is minus 2q. This is 2q. No. So how can this, beta? This is, I can see step number 2, my dear. Right, beta? So now this is minus 2q. And this is, beta, I can see charges over here. So this is, you can see direction of this dipole moment. This is what direction of this dipole moment. This is, my dear, already mentioned the question. This is what 2q. Beta G, this is also A. This is also A. What's the separation between the dipole? You can find from Pythagoras theorem, PT. This is what, my dear, root 2A. This is what root 2A. Beta, here again I'll find because this is what P2. So what is the magnitude of P2 beta? This is what you can say 2 to the what beta? Tell me here. This is 4 times of QA. Here I'll not write direction because this is at an angle 90 degree. So now students, I'm explaining slowly here. It's a good question beta so that you can understand, you can get benefit of physics points. Now beta, this is basically directions of P2. This is what beta direction of P2. What is the angle beta? You can say easily. You can say easily, my dear. This angle is nothing but this is 45 degree. This is what, my dear, 45 degree. But I know dipole moment belongs to quantity. Because a dipole moment belongs to quantity vector. If any quantity belongs to vector, so you need to take component. So you need to take component. So what beta I can say? P2 cos 45, P2 sin 45. So no beta, P1 already in this direction. So students, here you can write this is P2 cos 45 degree plus beta, this is what? P1. You can say entire along I cap. Now, student, this is P2 cos. Always angle making, you can take always cos. This is my dear, you can write what beta? P2 sine 45 degree. So beta, just this is I can see z cap. So student, now I'm going to write final answer of this question because they ask what is the net dipole moment, which is what? Step number 4, my dear. Which is student, I can say step number 4, right? Okay. Bacha ji, step 4. For writing, I can say dipole moment net is equals to what, beta ji? You can say P2. This is cos 45 degree plus P1 beta I cap minus beta P2 cos 45 degree. This is, I forget here. You can multiply bacha by root 2. What is the operation bacha? P2 cos 45 degree. What beta ji? J cap. Now beta, P2 we already found here. How much? 4Q A root 2. I hope all of you remember here. I'm expecting at least this cos 45 1 by root 2 which so you can say 1 by root 2 plus beta g. What is P1 here? 4QA. This is 4QA beta. You can write I cap minus beta. P2 remains same here. What is P2 bacha? 4Q root 2a into beta g 1 by root 2. You can see root 2 cancel beta. Root 2 cancel beta g. So what you can write 4 plus 4. फिर बच्चा party 4 plus 4 beta what? 8. This is right now beta party. What you can write here? This is 8 I cap. बच्चा 8 Q A I cap. Then बच्चा party what you can say? Minus 4 Q A J cap. Beta, you can take common here. You can take bacha the common. Beta, how much you can take common here? Bacha, you can take this is 4 QA. But you can see there is no option at all here. So this is 2 I cap minus J cap. 2 I cap minus J cap. Beta, where I did wrong here? Check once. Student beta, where I did wrong here? Because this is as usual remains same only beta. Okay. Check here once because there is no any option at all. P2 cos 45 root 2 cancel. This is 4a, 4QA beta, 4QA, and this is 4QA. Yes, correct only. This is 4QA, and this is root 2 cancel 4QA. Maybe there is some error. So this is the way. This is this. I mean to just say what is the logic of the question. Logic I explained this one, right? Now, have a look at our next questions here. Again, I can say it's easy question. This question, you can basically gravitation student, Shreyans. Shreyans, beta, this question from gravitation, right? Which will start by tomorrow. But I'll take time to start this topic, beta. So this is question from 11th class, gravitation only. What question says, beta? What question says? Student, I can say there are two. I guess initial. This is case initial. An equilateral triangle. An equilateral triangle. Okay. Okay, you are only. Very good. Very good. Very good. Very good. Very good, beta. Very good, my dear student. Now, bacha, then you can come, bacha. You can understand, beta ji. This is 20 beta. Initially, beta, you can say this is 20, 200 kilogram, 300 kilogram. Two. This is the initial condition. What is the side of a triangle? That is, I can say, bacha, 20 meter. Yes, beta. You are my favorite boy, na, beta. So you are always, whatever I'm doing, you will be with me only. Then beta, I can see next triangle. This is beta, same triangle, masses remain same, side got changed. So we have to find what is the work done, right? So beta, for finding work done, here I'm not just solving, and beta, I can see only questions here, right? Just I'm just giving concept as well, my dear. So here, students, what I can say, Bacha ji, this is students for the things which you can keep in your mind. Beta, this is I'm calling point one. This is two. This is three. Right, my dear? Okay. So what is masses beta is mentioned here? This is 300 kilogram. Okay. Then Bachaji here, this is what my dear? 400 kilogram. Then Bachaji, this is 200 kilogram. Okay, fine. Beta, this question I taught you, beta. I taught you, beta, during I can say JSO. So, beta, you can just be calculate answer with me, beta. So, first I want to tell you what is the formula which we wish to find, because work done is what? Work done is what, beta? Change in potential energy. Work done due to external agent, beta. What you can write, my dear? This is basically you can write change in change in potential energy. Change in potential energy, my dear. Right? Okay. So what is change, beta? This is you can say U final minus U initial. Okay. So beta, now this is student I'm finding. This is students I can say for initial case. Right, my dear? Okay. So for initial beta, just I'll make pair here. Unit. This is what beta? First, this question you can solve by CBSE method beta. I hope all of you remember. This is what my dear? U1 due to 2. This is first pair beta. This is beta what I can say first pair. U1 due to 2 plus beta what you can say U1 due to 3. This is first pair. This is second pair. Then beta you can say U2 due to 3. U2 due to 3. So you students, I can say you want due to beta. How much formula? I hope you remember. What find potential energy for here? Not I'm solving questions only. I'm giving concept as well. Potential energy for a pair of mass m1 and m2. This is what our students. So you can write this is minus g m1 m2 by r minus g m1 m2 by r, my dear. Right? Okay, u1 due to 2 beta. So this is first pair I'll take. So this is minus g m1 beta 300 m2 beta g 400 g m1 m2 by r. This is Benson Bachar party. This is okay. You can type there also beta. You can type there also beta. Very good beta. U minus g beta 300 into 400 beta g. Upon beta what I can say? This is what? 20 bacha ji. Right. Then bacha, you 1 due to 3 beta. This I'll take care. This 300, 200 bacha. Minus g into beta 300 into beta g 200. This is remains same bacha party. Minus here. You 2 due to 3 beta g. Minus g bacha 400 into 200. 400 into beta g 200. Upon beta g 20. This 2 simplify bacha party. You can take beta, this is, I can say minus, you can take beta, it's common here, minus g by 20. Beta, this is what? Till here, 300 plus this is what? You can say 1200. So 12 into 10 to the power 4 plus beta, 6 into 10 to the power 4 plus beta, 8 into 10 to the power 4. Now, beta, just do further beta, minus g by 20 10 to the power 4 beta you can take common student 12 plus 6 18 18 plus 8 beta 26 26 beta this is initial potential energy this is what dear initial potential energy now students I'll find yes very good beta very good my dear now beta ji have a look beta I can see next part I can see bacha this is case 2 case 2 what is bacha this is masses remain same but side squint increased by 4. So you can tell, my dear, this is 200 kilogram. This is 300 kilogram. This is what bit is 400 kilogram. So again, I'll make pair here. So this is 1, this is 2, this is what, my dear? 3 only, right? So straight again, I'll apply same formula which I applied previously. So U is what beta? U1 due to 2 plus beta u1 due to 2, 1 due to 3 plus u2 due to 3. So beta same thing you can apply beta g minus g m1 m2. This is you can say 1200 uh, or again 100 beta party upon beta g 20 minus beta what you can say this is 25 here my dear my bad my dear this is mentioned here 25 this is basically changes in this question 25 beta party minus beta I can say g into beta this is you can see beta 3 to the 6 into 10 to the power 4 upon beta what we can say 25 then beta g what you can say minus beta g this is what 4 to the 800 means g into 8 into beta what 10 to the power 4 upper beta what we can say this is 25 beta what we can say this is the 25 right then bacha further we can solve here further beta we can solve for getting answer of these questions so beta this is u final beta how much will you get here u final beta what is the masses same na bacha masses remain same yes u final one is u initial okay. So here, bacha party, you can find u final beta. U final beta, how much will write? Okay, okay. Yes, beta ji, correct here. You can write this is same only bacha. U final bacha party same. So I can say bacha party, we can just further apply what is the answer we are getting bacha party, right? Beta, what we can say? Minus g by 25. 26 beta what? 10 to the power 4 in joule. Then beta further we can apply here. Work done is what my dear? This is U final minus initial beta. What beta G mentioned in the questions here? 6.67 10 to the power minus 11. What my dear? Newton meter square per kilogram square. Right. So further you can solve my dear, you will get answer of these questions. Actually, very good here. Those candidates till night 11 o'clock staying in the live session. Very good, bacha. All of you stay blessed. Now, beta, what's the questions? Dipole is placed in uniform magnetic field. That is, beta, that is. This question, student, I can see from 12th class. I in the classroom I discuss beta Z. In the classroom, student, I discuss. What is the SI unit beta of magnetic field? That is what takla. That is what takla, right, beta? So this beta, I can say 800 Gauss at an angle beta. What they mention? This is 30 degree. Then it experiences a torque. Okay, it's I can say beta. It's a good question here. It's a good question, Bachadi, right? Experiences the torque that is mentioned student. Yes, beta. Correct, beta ji. 16 into what? 10 to the power minus 3 Newton per meter. Find the work done slowly moved the dipole stable to unstable. Easy, you can do. You can do, beta ji. Now, have a look, students, for the question first. Right? Because for beta getting work done, you need to find magnetic moment as well. You need to find what, beta ji? Magnetic moment as well. Okay. And so how can we find beta magnetic moment here? So beta first torque is mentioned. You can use beta formula. Torque is what beta? I said in the classroom here M cross V. So here beta what you can see? This is M beta. Torque is mentioned here. How much torque? Torque beta ji 16 into 10 to the power minus 10. What is the magnetic moment we used to find here? And B beta what? This is convert beta in SI here. Magnetic moment, this is what 800 Gauss. I hope you remember here, 1 Tesla is what 10 to the power 4 Gauss. So 1 Gauss, what you can write? 10 to the power minus 4 Tesla. You can feed over there, bacha. Then magnetic field beta, what will you get? 8 into 10 to the power minus 2 Tesla. Right? Beta, I'll use over here, bacha, party. So here, bacha, you can say 8 space place here. So I'll beta use this space, right? So what my dear? This is torque is mentioned 16 into what beta? 10 to the power minus 3 beta we used to find magnetic moment beta this is what mb sine theta sine 30 1 by 2 beta so you can write 8 by 2 into 10 to the power minus 2 beta we'll get magnetic field from here only just you can say beta cancel 2 for the 8 so beta 4 for the 16 you will get beta m is what beta magnetic moment how much here will get M beta J, magnitude moment, how much will get, bacha? 16 upon beta, this is beta J, I can say 10 to the power minus 2, na? So we can write beta 4 for the 16. 16 into beta 400, na? 400. So 16, 4 4 ja 16, 4. 4 by 10. And beta, how much will get here? M is what? Basically 4 by 10 beta. This is the magnitude moment. Very good evening, student. This is beta 4 by 10 magnetic moment, right? You can say which is E. Then we can apply. What's the condition beta? There is two condition here. Student, this is I can say my dear. There is the condition. This is case one. Your entire system in stable condition. You can understand a student. Stay in the live system only. You know, beta. For this condition, what you can say, angle between magnetic field and beta what? You can see dipole moment. Both are what? Zero. For stable condition, beta. Keep in your mind. Now, beta, case 2 is what, my dear? Case 2 is what says unstable condition. Student, case 2, what you can see? This is unstable condition. So, beta, for this condition, you can say M and B. Beta, magnetic, member, beta, magnetic field, this direction, beta. This is a dipole moment. So, M and B, beta, you can say both are anti-parallel. Both are beta what we can say anti-parallel. So we have to find work done. I can say beta here I'm going to use your one formula of electrostatics that is a part of electro. I can say two beta, but I can also compare in magnetism as well. You use beta, in electrostatics, beta, what we remember minus P dot E, or you can say P cos theta. So same formula of electrostatics you can apply here as well. So this is what, my dear, minus this is M what beta is B into beta, you can say cos theta. Simple. So student, you wish to find basically work done. So work done beta, this is I can say this is last step beta for calculation. Work done you can write U final minus U initial. Simple beta. So for I can say this condition unstable, students you can take theta is equals to 180 degree. Theta is what, my dear? 180 degree, right? So here, bacha, what is U final here? U beta you can say minus M B. Beta, what's the beta initially question? What's the bacha body? This is beta they mentioned here. Uh, Stable equilibrium to unstable equilibrium. This is the final bacha. MB beta, this is the final MAB beta cos 180 degree minus what beta you can say? This is MB cos 0 beta. Again, I'm repeating beta Z. This is student, I can say for unstable condition, which is the final. This is stable condition, which is the initial, my dear. Right. So M beta we already found 4 upon 10. So you can see beta minus cos 180 minus 1. So minus minus you can write beta. This is plus 4 upon 10 beta z. And what is magnetic field we found here? This is 8 into 10 to the power minus 2 beta. Okay. Then what's the party? You can say minus. Magnetic moment what's the party? Again, we can use same 4 upon 10. Then beta, what we found here? 8 into 10 to the power minus 2. Cos 1 what's the party? Then beta do one thing here. I can say, bacha, this is the minus and minus here. This is what? Minus minus beta plus here. Because bacha, this is cos 180 degree, bacha. 16 by 40, 8 into 4. This is beta minus minus plus here, something. Beta what we can say 448. This is same thing we are getting, bacha. You can say 4 8 is 32 by 10 into beta 10 to the power minus 2 plus beta 4 is the 32 upon beta you can see 10 into what 10 to the power minus 2 beta comes down here and finally you can solve beta but 32 plus 32 beta what becomes 64 beta you will get this is 0.64 correct correct very good my dear very good my dear I'm very happy beta I'm proud of you beta minus 2 बच्चा जी. So what you will get 6.4 into 10 to the power minus. Very good बच्चा. I'm very happy with you बच्चा. Very happy, literally. Mind blowing बच्चा. So but I can say option first is correct. Option first is correct. I'm very happy to see all of you join Physics Point. All of you welcome. And see Physics Point, watch a regular Physics Point channel. You will get everything which you wanted knowledge in the physics. Now, have a look next question, sir. Which is question number 3. I'm going to discuss this one. Current through, we have to find 10 ohm only. Current through 10 ohm, right? So here, I'll apply little manipulation. What which this is beta I can see 20 volt. This thing beta I'll just go to arrange over here only. So what beta I can see this is basically 6 ohm. Baby is to find current through 10 ohm bacha. I can rearrange bacha either 10 here or we can see 10 here bacha buddy. So I'm just connecting for here only bacha. This question is what I did here during GSO preparation beta 4. This is 10. This is 10 beta. This is 7. 5 plus 2 beta. This is 20. Student, you can apply junction law. It's very simple, student. Student, simply you can apply beta junction law. So what's the junction law beta? I hope all of you remember. This is a higher potential beta G. So I'll apply here what? Current junction law beta. Summation of I which is equals to 0. What beta you can say this is x. Yes, beta. Correct. X minus 20 beta upon 7 plus beta what you can say x minus 0 upon 10 plus beta g x minus 10 upon 4 is equals to 0 beta. Just take LCM here. How much will you get? This is beta you can solve here. This is 240. This is what beta you will get here. This is basically 240. This is what beta you can say 240 here. So finally, which just solve further here. This is x 240 means this is 20x. This is 24, 44, 25. Beta I will get here finally. This is 69x minus beta 750 is equal to 0 here. So x beta what will get 750 by 69. Now, beta, we used to find current over here with us. What is current with party? V by IR. So this is V itself. 750 by 69 beta into 10 cancel here. So you can say 75 by 69 ampere beta. This is the answer for beta for this questions here. Something I don't know how this is. Have a look beta next questions here. What say beta questions? Again, it's a beta. I can see unit dimensions error. This is what my dear. I can see unit dimensions error. Right. So beta party will go through these questions here. Hmm. Correct, beta. Correct, beta. Very good, my dear. Beta, this is the magnetic flux. Then magnetic permeability, magnetic induction. Student, magnetic induction, you can also see this is the magnetic field. There is this is a self-inductance. Half LIS, sorry, energy beta we can find. So beta, magnetic flux was also here. I can see beta for solution. What is magnetic flux? This is, you can write beta magnetic field, B into A. Simple, bacha ji. B is what beta I can see? Tesla into beta area. But you need to find beta what is the Tesla dimension formula. Beta, this is, I can say, step 1. Step 2, beta ji. You can use your force formula. F is equals to what? ILB. F is what beta is the ILB. So B is what? Magnetic field here. So you can write beta. This is what? F upon IL bacha party. This is Newton beta. This is what? Current. Ampere bacha. Into beta length. So beta what you can see Newton bacha? M1 L1 T minus 2. M1 L1 beta T minus 2 here. Then beta ampere beta what you can say? This is beta what? Charge per unit time beta. This is what you can say Q by T bacha. So this is what you can say plus 1 beta. This elevator remains cancel here. So finally beta will get here M1 bacha this is what T minus 2 beta and this is what charge. Maybe answer in terms of ampere only. So no need to convert here. So simple we can write bacha M1 L1 T minus 2 beta ampere inverse beta. L we can say cancel. L we can say cancel beta. M1 beta what we can say T minus 2 ampere to the power minus 1. Beta we got only for magnetic field. Right, sir? We wish to find over here only, sir. Then beta, it is the area. What you can write? M1 L2 area which T to the power minus 2 ampere to the power minus 1. Just check here M1 L2 T minus. Is better. Option number B. This is what option number B. Same thing, bacha, we can just solve further, student, like magnetic permeability, induction, and finally, bacha, what's the thing here? A to 2. So I can say there is no need to solve beta. It's a heat and trial question, beta. It's a luck. It's a good luck for those candidates who I can say a part of this examination. Beta. This shift. This is no need to solve further. We have only one options, right, beta? So sometime luck is also favorable for you, but have a look next, beta. So what question? It's question, beta. I can say from FHM, simple harmonic motion, but it's a good question, beta. It's a good question, pretty good question, beta. What's the question, beta? I can say find time period of oscillation. So I can say, beta, for this question, time period is what, beta? You can say this is 2 pi by omega. Simple, simple, beta. You know, we just, beta, we analyze this situation here. Let us suppose you can take there is what excellent which is inside the beta there is mentioned here sigma is density beta good bacha good mera beta sigma beta this is density of beta I can say material and rho is what density of liquid beta g. So you know volume under water simple beta I can write here just justify relation here F is what directly proportional to beta I can say minus x here or you can say what f is equals to minus kx. This is the principle, basic principle for to prove equation belongs to assertion. So simple beta, we have to find force here. So beta here, I want to write volume under, I can say water. Students, this is volume under water beta. This is rho a gx. You know what I wrote? It's buoyancy. What I wrote, my dear, it's a basically buoyancy force, right? So, but I know this is the force basically. This is the force what only I can say responsible to create oscillation of this like say material. So, beta, what you can write? Simply, you can say, bacha, rho Vz. Very good, my dear. You can say, bacha, ji, for this condition, this is what, beta. This force is equal to ma, beta, I can write. Beta, it's a buoyancy force here. Just take beta negative direction. It's a restoring force. Rho A Gx is equals to what, beta? Ma. Now, bacha, just equate these two here. What is x? What is x, beta? No, acceleration is what? I hope all of you remember. This is omega square x. Acceleration is what beta we can say omega square x. So beta omega you will get from here only. This is what rho a g upon m beta. This is what rho a g upon m beta. This is the omega. Right. This is simple beta. I will feed this value in this equation beta. So this is 2 pi beta g. This is rho a g and beta. This is root of m. This is root of m beta. So what's option correct? Option number Bombay. Option Bombay is correct, my dear. It's a good question, sir. Now let's have a look at this question. I can say application of annulum as well as rotation. But it's a good question. Again, I can say beta as we have to find rotational inertia. Means beta, basically, what is the meaning of rotational inertia, my dear? It's nothing but you can say it's a moment of inertia they are asking. Simple, Bachaji. What's the question? When system is released from rest. Okay. So have a look. I can see it a solution. U is 0. Okay. The heavier mass, beta, this is 450 gram, my dear. This is what, my dear? I'll write here for you easily understand. 450 gram, beta. Ji. So heavier mass is what? Coming down in 9 seconds. How much, beta? Ji? This is 0.18 meter. So simply we can find what's the acceleration of this body, right? So for getting acceleration of student, you can apply equation of motion second. That is what, my dear? S is equals to half of AT square. S means bacha 0.81. 0.81 beta 1 by 2. A we wish to find. Time is 9 seconds. 9 9 is 81. This is cancel here. So acceleration will get 0.02 meter per second square. Simple as usual. Student, there is a no, there is a short trick here. I gave this formula multiple times in the classroom. What's the short trick beta? For this kind of questions, acceleration beta I can simply find here. What is the acceleration beta for this case? This is m2 minus m1 into beta g. This question, beta, this formula they already asked JEE main first day, first shift. So we remember it's a recommendation for those candidates who will go to write exam, beta. So this is what M2 minus M1. upon beta what we can say m1 plus m2 plus beta what I upon r square. A beta mentioned for us. Just beta feed the value 0.02. Beta mass beta this is what m1 beta m1 minus m2 bacha. What we can just beta just this subtract these two. So beta you can write this is 0.15 kilogram into beta g. I'm taking 10 bacha party. Right. In fact, g also already mentioned beta 10 only. M1 plus M2 beta, what we can see? Beta in kilogram, 0.75 plus beta. This is, you can see I. And R beta means in 1 year, so 1 only. Just beta, do cross multiply. 0.02 into beta, 0.75 plus I. Beta, this is, you can see beta 1.5. Solve beta further here. I will get further beta, this is 74.25. Don't forget unit kilogram per meter square. Hence options America is correct. Hence option America is correct, beta. Very good, my dear. Now, beta. Next question. Question number I can see it's say 17 which binding energy per nucleon always. It's question beta from modern physics 12th class. Binding energy per nucleon always increases with mass number. No, it's wrong, bacha. You can see here. You can go through diagram. Simple, beta. Binding energy per nucleon, right beta? Binding energy per nucleon bacha. This is I can say beta condition there. I gave short trick. This is letter M. This is letter M bacha. So beta I can say statement one beta wrong only. What's the next question? Binding energy per nucleon for smaller mass number always performs nuclear. This is I can say beta statement two correct bacha ji. Have a look at next questions here. Again, it's a good question, beta ji. But here it's easy. Here, student, it's easy questions. A, B, and C. That is mentioned. No need to find acceleration of A block, B block, C block, and all. No, no, not at all. Right. I can see what's happening for this question. What's the point which you can apply? Simple, bacha. No, what's the question? Find the value of F. This is beta. I forget it. This is mentioned in the question, beta ji. Applied force on block C only, so that block C moves with constant velocity. You know, beta, what is the meaning of this constant velocity, beta G? I can say, beta, for solution, constant velocity, what implies, beta, acceleration is zero. Acceleration is zero, beta, means what you can say, entire system is at what? You can see in equilibrium. You can't say rest, is in what? Equilibrium. So all forces remains balanced. All forces what remains balanced. There is an interesting point, beta. Tension acting on block V. So it's a I can see no, these two block definitely will move together. Definitely what will move together only. So beta, these two block you can take a common system. How beta? Just have a look. These two block can be a common system here. So what is block A? 4 and plus 6 beta 10 kilogram. This is beta I'm considering here according to concept here A plus B both become a common system. This is what 10 kilogram. Now beta, this is direction of what? Tension force over here. So what is the direction of friction beta party? This direction here. So friction you can write, it's nothing but it's a basically mu1. Friction is mu1 which are correct, my dear. But a friction you can write what which are this is basically 50 Newton beta because mu mentioned 0.5. Beta then make FBD. This is I can say beta I don't FBD of both of the block. This is the students, I can say FVD of block C. This is remains tension T. No, but this direction friction in because these two are in contact B and C. So this block, I can say direction in this direction of friction. So due to this block, direction of friction in this direction here. So you can write over here, this is what basically 50 and applied force beta towards right only. Now you can see system is in equilibrium. So from here, I will get a value of tension. You can write tension is equals to 50 Newton, my dear. You can write what here? T is equals to 50 Newton. Now, beta, system is in equilibrium. Then you can equate this force, beta. Force is equals to, we wish to find this force. This is what? 50 plus 3 beta. 50 plus T. And T is what? 15 Newton here. Already we got. So you can beta. F is what? Basically 100 Newton. It's an integer type question, student. It's a easy, which I can say, which I have done in the class. That is more tough, but it's literally easy, beta. Now, beta, have a look next question here. That is question number 19. What question says, Bachaji? That is a light ray incident on the prism such that deviation is minimum. Okay, that is a clue for the question, beta. Deviation is minimum, beta. What implies you can say R1 is equals to R2, or beta you can say A is equals to 2R. This is the consideration here which I have already done in the classroom. Beta, they mention here we have to find prism angle, means we have to find A. So A is equals to 2R. So we can find R, bacha. R will easily get here. How? Because light coming from here. So beta, there is a refractive index of prism is N. And beta, environment is what? N by 2. So we can find first what is the formula of sine C is a critical angle, beta. I taught beta already during GSO preparation here. So this is what, my dear, NR by, you can say ND. Right? NR is what? 1 by 2 here. So you will get critical angle is what, beta? This is what basically 30 degree. So this is what beta. You can see here. You know what the question says? Minimum deviation here. Beta, so light will go like this. Light beta will go like this. Beta. This is beta angle deviation. Beta, you know what's the angle here? This one. This is 90 degree beta party. So this is what beta already we got. This is beta ji 30 degree. This is 30 beta. So A is what 2R beta. So beta, what is A beta? You can see this is 60 degree, which is option number D. Which is what, my dear? Options number D. All of you stay blessed, stay in the lives at this point. All of you welcome. Now, bacha, next question here. Velocity, this is the last question as well for this discussion, live session. Velocity of electron in nth cell of hydrogen-like atom is what, students? Beta, 3 into 10 to the power 5 meter per second, and velocity of electron in mth cell. Okay, simple, student. It's a very simple questions here. No, I repeated multiple time in the classroom. I said multiple time in the classroom, my dear. No, what's the solution, beta G? You can say, beta G, for this question. I hope all of you remember here. Velocity of nth orbit. This is beta what? V naught into Z by n. And beta, what is the radius formula for nth orbit, beta? This is R naught beta. You can see this is N square by Z. This is the condition beta, which you can always keep in your mind. Which event you can always keep in your mind. Right. This is beta Z upon N bacha. So they mention bacha party. Just we can take bacha party. How much? So velocity bacha, I can say velocity of beta. I can take MS series. Upon beta, what is initially beta? Velocity of what? I can say beta nth cell. Okay, my bad beta. This is velocity of n upon beta. What? Velocity of m beta body. Right. What beta we can say? 3 upon 2.5. Power cancel na beta. Power 5 both. Then you will get this is what? 6 by 5. What is the concept of beta? You know, this is z by n. N square by z. So this is entire square by beta. So you can use one relation here. Radius of beta what? Mth upon beta radius of nth. What was party? You can see this is velocity of beta. This is reverse here. So velocity bacha party, you can say m upon n bacha. Okay, this is beta. You can simply say 6 upon 5 beta whole square, which is what? 36 by 25. So 36 by 20. Option number C. Option number C, my dear. So stay blessed, everyone, student. I'm very happy to see till now. You stay entire live session, beta. Now I'm going to terminate this live session. I'll again be live around 3 o'clock in the morning or 2 o'clock. Yes, beta. Now I'm going to live, beta. Just terminate the meeting. Yes, beta. God bless you all, everyone. Stay blessed. You welcome at this point. You can connect always. This point will help you according to your expectation. Correct, my dear. I'm going to terminate your meeting. All the best, everyone.